Assalamualaikum and very good day. My name Nur Syarah Hamid Yusof, final year student of University Technical Malaysia Melaka. Today I will present my project demonstration with title analysis of leaf identification performance using machine learning approach. My project demonstration will include the introduction of project, methodology and the result. So, let me introduce my project. The knowledge of leaf species is very important for people, especially for botanists. Many botanists use manual identification to identify the leaf, but this manual identification is often time-consuming and ineffective method. Therefore, there is an effective method to identify the leaves in terms of the feature extraction process. But there are several feature extraction to identify the leaves, such as color, texture and shape. For the recognition pattern of the leaf, its feature extraction give different output. Therefore, in this project, various learning techniques for classifier have been used to perform leaf identification using high performance statistical approach and for the feature extraction. But its technique in this classifier learning has a different performance and time processing to perform on identification of the leaf. So, to solve this problem, this project aims to analyze leaf identification performance using a machine learning approach in terms of classification accuracy and processing time. And the second objective is to extract feature for leaf identification by using the statistical based feature. This is flowchart for my project, which include the image acquisition, image pre-processing, image segmentation, feature extraction and classification. The first step for this project is to acquire the image of the leaf. In this project, the Kaggle dataset was used, which contained 4,089 images for 4 different species leaf. It contains images of plant leaf which are in .jpg format. For this feature extraction involve statistical based feature. Statistical based feature is subset of color and texture analysis. And for classification, after we do this classification, we do analysis in terms of performance and time processing. Next, for image pre-processing, the RGB color of leaf was converted to grayscale image. This is simulation, one example of type of leaf that convert this RGB color image to grayscale image. For the next step for this project is image segmentation. Image segmentation for this project includes the region of interest (ROI) for the leaf image. In this MATLAB software, there are image segmenter toolbar that can use for this stage. For this image segmentation, we have 4 type of we call ROI, which is a threshold, graph guide, local graph guide, and fluke field. This overall process to crop, we call it segmentation. For this project, we use a fluke field techniques. This fluke field techniques is used to crop the region of interest of the leaf. After we do this segmentation, we export this image to workspace and generate function for this segmentation. This is result for image segmentation for this leaf image. Last but not least, the feature extraction one is step for this project. After pre-processing and image segmentation, this feature extraction was applied. In this feature extraction involved the statistical based feature, which involve the color and texture feature extraction. For color based feature, involve the statistical value such as mean, standard deviation, kurtosis, and isoquiners. While for texture feature, involve the entropy, contrast, correlation, energy, also the homogeneity. This is one example of statistical value, which is the value of mean. Last stage for this project is the classification learning. In this project, supervised learning classification technique such as SVM, Naive Bayes, KAN, assembler, decision tree, and discriminant have been used. Let's see how it works. From this, the higher accuracy of each classification technique was be taken. For tree decision is 78.1% with 4.97 for 2 seconds. For discriminant is 79.8% with 1.45 to 5 seconds. For Naive Bayes is 63.8% with 3.90 to 9 seconds. For SVM is 86.9% with 2.639 to seconds. For KAN is 81.6% with 1.0857 seconds. And the last one for assembly is 85.1% with 6.020 seconds. From this classification result, the SVM technique has the highest accuracy, which is 86.9% with less time processing, which is 2.6392 seconds compared to the other classifier technique. From the obtained result, the graph performance of different classifier was created. From this graph, the SVM classifier has highest accuracy with 2.6392 seconds, followed by assembly classifier, but with 0.2020 seconds for time processing. Therefore, the SVM technique is good classifier techniques for these leaf identifications compared to the other classifier. For sustainability, the machine learning can provide more accurate and faster result analyzing the leaf identification, which carries more information about the leaf properties. For environmental, it has come up together with big data technologies and high performance computing to create new opportunities to solve, measure, and understand data-intensive processes. For the research potential or marketability, the market graph of technology increased nowadays. Since we are in COVID-19 pandemic, the potential market of this project will be stable because people nowadays using machine learning to make their job easier. Like this project, we help botanists to identify the leaf without hire expert people to help them to do this job.